So part 2 of simultaneous equations is actually realising what it is we're trying to find. So we have two equations. Here we have two equations, both for straight lines. One is y equals 3x take away 2, and the second is y equals negative x plus 4. Now our learning intention for today is to understand that solving these two equations to find x and y means finding the point of intersection of two lines. So what is the point of intersection? The point of intersection of these two lines is the point that they cross over each other. So if I was to mark it, it is this point right there. And if you, by looking, which in an exam is actually a valid way of finding the point of intersection, you're allowed to read it off the graph, you will have 1, and it's midway between 1 and 2, so we have 1.5 on our x-coordinate, and up the way we have in between 2 and 3, so flat bang in the middle we have 2.5. So our point of intersection, and I'm going to do that in a bright orange pen, so we have point of intersection is when x is 1.5 and y is 2.5. Now I said before, solving simultaneous equations means that we're going to have to do some adding and subtracting, and we're going to manipulate the two equations at the same time in order to find x equals, and then we sub that in to find y equals. You can also do that the other way around. So you could find y first and then sub in for x. And I'm going to show you how we do that using these two equations. So we had y equals 3x minus 2, and we had y equals minus x plus 4. Okay. Before we start doing any adding or subtracting, there is a check I need you to do every single time. First off, you ask yourself x or y. And what this means is, does either the x's or the y's have the same value in front of them? So it's quite easy to look and see that x has 3 and minus 1. That's not going to work. But if we look at y, we can see that actually they both have that imaginary 1, the one we don't bother writing down. So we are going to be able to get rid of our y's. Whichever thing you circle there should disappear after the next step. The second thing you ask yourself is same signs. Once we've found either x or y, we have to look and ask if they have the same sign in front of them. So, y was the same. These are both positive. So because they are both positive, they have the same sign, we are going to subtract one from the other. If they had a different sign in front of them, we would add. So if one was positive, one was negative, we'd add our two equations together. But because they've got the same sign, we are going to subtract. It's got all the S's, all that lovely alliteration in it. And the way we do this is we set it up like a chimney sum. And we just go along. Just putting brackets around it so remember we're subtracting the whole thing. So we have y take away y gives us 0. we have 3x take away negative x. Now remember, take away a negative, it ends up a positive. So we're going to have 4x. And then we have minus 2 take away 4. And that is going to leave us with minus 6. So we have, apologies, that's my dog being demanding because she thinks she needs 3 meals a day. Shh. So we have 4x take away 6 equals 0. And we're going to solve this like one of our classic equations. We are going to move the negative x across, and that's going to become a positive. So now we have 6 equals 4x. But we don't want 4 lots of x, we want 1 lot of x. So the 4 is going to have to go across, it will become a divide by 4. And we end up with x equals 6 divided by 4 equals 1.5. Now, I'm just going to show us this again. X equals 1.5, x equals 1.5. So this thing about solving these equations simultaneously gives us that point of intersection seems to be true. But we've only found x and we need to find y. And this is our last little step, is we say, well, we're going to just substitute in. You can substitute to either of these equations, it does not matter. Now, because this one involves multiplying the x, I'm going to avoid it. And what I'm going to say is sub in. So I'm going to have y equals minus x plus 4. That x is going to become minus, it's going to be 1.5, so it's going to be minus 1.5 plus 4. And that equals 2.5. Now, if you've been asked for the point of intersection, you have to say point of intersection equals 1.5, 2.5, and this matches up perfectly with what we have here.